A very good afternoon to all. I, Chetana HD, Assistant Professor, Department of Computer Science, and a faculty member of Wing, would like to welcome you all to this 3 days workshop on network simulators organized by Department of Computer Science and Engineering in association with Wing in collaboration with UCSP NIE Mysuru. I would like to take this opportunity to welcome Dr. Ravi Kumar V, HOD, Department of Computer Science and Engineering, for this workshop. I welcome you, sir. I
Thank you,
extend my
madam.
warm, I extend my warm welcome to our Wing faculty volunteers, Dr. Gururaj H L and Professor Jan V, for this workshop. I welcome you, sir. I welcome you, ma'am. I extend my warm welcome to Dr. Vijay, Assistant Professor and UCSP Coordinator, Department of VCE, NIE Mysuru, in his absence. I, will, I extend my warm welcome to all the participants for 3 days workshop on network simulator. I welcome you. Now, I request Dr. Ravi Kumar V, Professor and Head, Department of Computer Science and Engineering, VVCE Mysuru, to say a few words.
Good afternoon to one and all. Dr. Gururaj H L, the resource person as well as the wing coordinator, Dr. Chetana H L, and other faculty members and my dear students and faculty member from the other institution also. And also I thank UCSC, NIE for having collaboration with Wing. So I hope Dr. Gururaj H L is doing his best from past many years from our institution, being a resource person for this particular workshop. I mean, it's a particular topic, network simulator, and also he has his own YouTube channel also. I think these 3 day workshop will enlighten all of you on the how to use the simulator, network simulator, and also it helps the students of fifth semester to use the simulator in their lab. I hope Dr. Gururaj H L will give more light on this particular topic. This workshop will enable the faculty members to take up some research also. So with this, I wish this workshop to be a fruitful and thank you. Over to you, madam.
Thank you, sir. Now, I request Professor Swati BH, Assistant Professor, Department of Computer Science and Engineering, to introduce today's speaker, Dr. Gururaj H.
Thank you, ma'am. Good afternoon, all. It's my immense pleasure to introduce today's resource person, Dr. Gururaj H L. Dr. Gururaj H L joined the Department of Computer Science and Engineering at Malnad College of Engineering as Assistant Professor in July 2013. Currently, he is working as an Associate Professor in Computer Science and Engineering, Vidyavardhaka College of Engineering, Mysuru. He received Young Scientist Award for International Travel Grants from ITS SERP DST, Government of India, in December 2016. He has been involved in research projects in a range of settings, including agriculture, health, education, arts, culture, and community. He leads the research and development community wing, that is Wireless Internetworking Group. He is the author of over 75 publications and he is currently on the editorial board of 3 international peer-reviewed journals. He has served on numerous conference program committees and also as chairperson. He is a multidisciplinary computer scientist who has worked on computer network and its application for the past 9 years. His contribution towards QoS aware network congestion control, network security, cloud computing, and machine learning is tremendous. He delivered many technical talks and honored as resource person in various national workshops on network simulators. He is an ACM professional member and faculty sponsor of ACM VVCE ACM chapter. We are very much fortunate to have as our today's resource person, sir. I welcome you. Unmute, unmute.
Thank you, ma'am. Now, I request Dr. Ravi Kumar V, Professor and Head, Department of Computer Science and Engineering, VVCE Mysuru, to say a few words.
Unmute, unmute.
Thank you, ma'am. Now I request Dr. Gururaj sir to take over the session. Over to you, sir.
Well, good afternoon, everyone. Respected Head of the Department, Dr. Ravi Kumar sir, faculty program coordinators, Professor Chetna HP and Professor Swati BH. Uh, I'll start the session without taking much delay on other aspects. With the able guidance and support of our HOD, we are conducting the same workshop from past many years, and now this, I think there's a fourth or fifth workshop, I don't remember. We're having in our institution the same workshop, network simulator. And once we prepared the manual for this, almost all parts of the Karnataka, all the colleges, they're using the same manual what we from the Vidyavardhaka what we prepared. So guys, we'll start with the things. I'll go with the brief introduction towards network simulators, why we require network simulators, and why they had incorporated in your syllabus and other things. And later on, I'll go with the concepts of in detail concepts of syntax and semantics of network simulators too. And I'll go with the hands-on experience for you people, because you have to see how it executes, you have to see how the trace file works and all. So without wasting the time, let me give the brief introduction towards network simulator. Network simulator or simulator, if you would have heard of this name, immediately I think it's an animation kind of operation, correct? No? So here, network simulator, I think in the previous semester you might have been studied like PSpice simulator in LD or some logic design subject and all. Similarly, why we have to go for simulator before constructing any home or any building? What we'll do initially, we have to go for the plan, correct? No, we'll call it as blueprint. Okay, so why we have to go for blueprint? Because I don't know whether how much elevation, how much, how much bricks or how much sand or how much, all the materials required for constructing the building. Okay, simply start constructing without planning and all, it will be of no usage, correct? So in a similarly, network simulator is very much required before constructing or before deploying any networks. Okay, it might be local area network, it might be a wide area network or larger networks or campus networks, whatever the type of network. If we have a plan, okay, accordingly we can able to go with the operation. Okay, so thereby which we can able to predict or able to analyze how much bandwidth I require, how much delay it may occur. All that things we can able to see with the help of the plan. Such planning can be done with the help of one of the finest simulator, what we have called as NS2, or we can also call it as network simulator 2. Okay, so quickly go with the details of that. In network simulator 2, okay, the 2, you might have a like a question, what is a 2? Why can't we have only NS or network simulator? That 2 is a version. Okay, immediately there will be a question. Okay, we don't have network simulator 1. Yes, it was emerged, and immediately it collapsed because of major pitfalls in that version. Okay, nobody is going to use network simulator 1 version, and one of the stabilized network simulator category is NS2. Okay, and it is an open source simulator, and it is freely downloadable. You can use or you can build your own modules whichever you want. Okay, all these features can be incorporated with the help of network simulator 2. That is a fantastic feature what we have in case of network simulator 2. Okay, and it was developed by UC Berkeley. I think majority of the students, you people have heard of this university, UC Berkeley. And why it is tricky, why not so simple? Okay, so usually people will have a question. Okay, network simulator, that too especially in NS2, if you would have heard, it's somewhat complicated language. Why it's called as somewhat difficult language? Because if you would have taken Java, Python, or any other language, they used to follow only one syntax and one semantics. Okay, but in case of NS2, they used to follow two syntaxes. Okay, one C++, or else I can call it as object-oriented language, and the other one called as combined language. Okay, it's a combined language, and that's to say combined language. Okay, and that is a major reason why somewhat it is the syntax and semantics are initially very difficult to understand. But once you are well versed with the things, you can able to do whatever the programming and all you want. Okay, and after some days, once you are well versed with this, you can able to build your own protocols. Okay, below me or not, Many of my students, they build up their own protocols, they come up with their protocol changes or protocol versions, and they publish the papers and all. Okay, so initially you might feel difficult, but I'll tell you the basics of each and every point, whatever the knowledge I have, I'll share with you guys. Okay, so it is a combined language, hence it is called as OTCL. Okay, why it's called as OTCL? The language is called as OTCL. The reason is that it's a combined language. O is nothing but object oriented. TCL is nothing but tool command language. Hence, this language is called as OTCL language. Okay. Commonly, people will call NS2 language as TCL. We can also call it as TCL. By default, object oriented will be used, or else specifically you can use it as OTCL. Okay, that is one important thing you have to remember. NS2 follows two languages, two combined languages. One is object oriented principles, not constantly C++. For your understanding, we used to call it as C++, not only C++. Whatever the basic programming of object oriented, you can have that in your mind. Okay, along with that, we have command language. Okay, what is command language? Can any examples for command language? The better example is Unix, Linux, and all. Correct? No, so it's a combined language of that Unix or Linux along with this object oriented, and combinedly we can call it as OTCL. Okay, and this language, one more feature is it's a discrete event driven simulator. There are basically two types of simulators. One is time driven simulator, and second one is event driven simulator. As the name itself tells about the simulator, time driven simulator is a category of simulator wherein which we have to give importance towards events. Okay, time. Okay, where I'll give an example for that. But in case of event driven simulator, we never bother about the time. Okay, it will always talks about the completion of the event, will give importance towards event. I'll give an example. Okay, I want to go from, for example, Vidyavardhaka College of Engineering to bus stand or suburb bus stand. Okay, how that is a task, that's an event, for example. Okay, if it is an event driven simulator, I don't know how much time I'll take to reach the destination. The complete event has to be completed in case of event driven simulator. But in case of time driven simulator, I'll fix up the time. For example, 5 minutes or 10 minutes or 10 seconds, whatever the time it might be. Wherever might be the destination, I may reach, for example, the next stop, or I may reach railway station, or I may reach in between. But as the time completes, I have to shut down the operation. Okay, so in case of event driven simulator, will give importance to the completion of the event. In case of time driven simulator, will give importance to the completion of the time. Okay, that is a major difference. Okay, but in case of this NS2, it is an event driven simulator. We will bother always about the completion of the event, not about the time. Okay, and time will explicitly will be given by the user. I can take, for example, I'll give an explicit time as first second to 5 seconds, or first minute to 10 minutes kind of thing. We'll see those examples while explaining the programming structures. I think you'll get to know all the things. Okay, and this is not only used for the lab purpose and all. This is widely used by many researchers across globe. Okay, my dear friends, it's not only restricted to the laboratory purpose or something like that. In the decades of 1990s until 2015, it was rigorously used by many researchers across globe. Okay, lot of papers, lot of new protocols they examined, they validated with the help of network simulator to protocol. Simulator. And as I said, it is an open source and free. And I think if you know the difference between proprietary softwares and open source softwares. Proprietary softwares is a version, whatever the limitation bounded or they had given, we have to use the same functionalities. But in case of open source, it's not like that. We can add up our own features, or we can build our own module. We can examine that module with the help of the tool. That's the meaning of open source. Okay, free is nothing, but it's not going to have any cost. It's capita free software. Okay. And this mainly works on wired and wireless networks. Okay, so this NS2 mainly works on wired and wireless networks. There is a third. There are basically three types of networks. One is wired networks, wireless networks, and semi-wireless networks. Wired networks is something that you can assume your lab, where in which we have a continuous, data cable connection between the devices, or it might be to the electric power and all. That is our Ethernet cable what we have. That's a better example for wired networks. Okay, or else you can imagine your telephones, old telephones, what you have in your homes and all. That's a better example for the better example for wide networks. In case of wireless network, in case of wireless networks, it's not like that. We don't have any connection or physical cable connection between the devices. That is a better example for wireless networks. Okay, there is a third category called as semi-wireless network. Okay, as the name itself indicates, semi is nothing but half wide networks and half wireless network. Okay, that network is called as combined network, is called as semi-wireless network. Okay, so that is one more important category what we have: wired networks, wireless networks, and semi-wireless networks. Okay, I'll give a better example for that. I have a cable connection with the help of landline phones. That is purely a wide network. If I want to make a call from that landline device to one more landline device or landline phone, that connection is purely wide networks. If I would have made a call from landline device to mobile device, that's an example for semi-wireless networks. Correct? Now, why it is semi-wireless? Because landline is a wide network, mobile device is a wireless network. The third category, what we have called as, I know the other one called as wireless network, where a communication call between mobile device to other mobile device. We don't have any physical connection between those two devices. Okay, so this network simulator 2 will support mainly for wide networks and wireless network. It will not support semi-wireless network. I'll tell you the greater details of that, why it's not supports, I think in the after a few time. Okay, and usually the main concept of this ideology of using the programming language of two different categories, the reason is that we have we have two ends. One is front end and back end. If I know just TCL combined language, I can able to do some operation on front end. I can able to create the nodes, I can do the communication and all. If you want to build some modification in the protocol or some network network concepts and all, you have to know very particularly about any object oriented language. Okay, that is the thing. For the laboratory purpose, you can able to, if you learn TCL perfectly, it's fine. But when it comes to the point of year, if you want to do something on that, if you want to go for the advanced thing and all, you have to do particularly, you have to learn particularly both the languages completely, thoroughly. Okay, this is the architecture of network simulator 2. Let me explain. If you learn this architecture perfectly, you can able to analyze all the codes of your, all the program codes of your syllabus, aram se. Okay, without not only the program codes, to say, whatever the TCL program you want to do it, the complete TCL programming can be done aram se with the help of this architecture. Okay, we have I'll tell you this. Okay, I'll tell you the result first, then I'll go with the complete architecture. Okay, as I said, this is a combined language of C++, object-oriented principles and command language. So we have an interpreter with the supported of libraries of C++. Okay, and hence it's a combined language. Okay, whatever the program you're going to write, that will be the input for this interpreter. Okay, this interpreter will execute the program with the help of the C++ libraries. Okay, whatever the program you're going to write, that's called as input for this architecture or input for this system, and the output what you get is called a simulation results. Okay, this part that part is called as combined part of two important languages, that is OTCL interpreter we require, and that will automatically run with the help of C++ supported libraries. And the program which you are going to write, it's called a script, and the output what we'll get is called a simulation results. Okay, what type of outputs we'll get? Obviously we'll get animation. Okay, I think you people know about animation. What the meaning of animation? Animation is nothing but movements of the nodes or movements of the graph, movements of the packets will be there. Correct? No. So as I said, you people, that I'm constructing the network animation things with the help of the simulator. Correct? No. So hence we require animation file. And that animation is, I think, that is Tom and Jerry animation kind of thing and all. So similarly, some kind of similar kind of animation we can able to build with the help of this part of the simulation result, and that is called as network animation. You can see here. And the second part of the result is called as analysis. How the analysis can be done? Analysis can be done with the help of, why we require the analysis, at what time, how much amount of data sent, at what time, how a packet has been dropped, at what time, which protocol they had used. All the details can be analyzed with the help of one of the finest file, what we have called as trace file. Okay, the first output of your simulator is animator file. Why we require the animator? To see the output. I want to see, right? For example, I have 4 laptop device and 4 mobile device. I want to connect all the things. I want to check whether the network is working fine or not. What I want to see in the output, actually, first I want to see the animation. Animation, why we require? To simulate. Okay, animation, why we require? To simulate, I mean to say, to visualize the output. I want to see the output. Okay, and why we require analysis? Okay, I have 4 laptop device, as I said, and 4 4 mobile devices. Okay, from the first laptop I want to send the data to the last mobile device. I want to see which laptop, at what time, how much amount of data, using which path. All those analyses can be done with the help of one of the finest file, what we have called as trace file. Okay, we'll see all the details in the upcoming upcoming slides, the greater details of each and every point. Okay, animation required to visualize the output, to see the output, and analysis required to trace file required to analyze the output. The third output is there, and that is optional output. It's called as graph. Okay, by default NS2 we have a default graph called as X graph. XYZ, that X. Okay, X graph. Okay, why it's called as X graph? It's the name of the graph. Okay, to make the graphical tool used in NS2 is different from the other tools. They had used X graph. Okay, we'll get graphs in Excel also. We'll get graphs in MATLAB also and other simulator tools. Correct? No? So similarly in this NS2 also we have the default graph tool. That tool is called as X graph tool. Okay, so these are the basic things you require to know about this. One is analysis can be done, followed by network animator. Network animator to see the output, analysis, the trace file to analyze the output, and the third is called this graphical tool. Why we require the graphical tool? To compare and to contrast. Okay, I want to compare first network with the second network. Okay, I want to check out how much data sent in first network and how much data sent in second network. Those comparison can be done clearly with the help of graphical tools. We'll see all the things hands-on also. I'll show you the execution also. Let me study before going with the 2 combined language. I'll give you the basics of command language first. Okay, and anyhow you people know some basics of object oriented language, and what is an object, how the object will be created, and all those basic things. We'll see that I think you know some basics of it. I'll also deal with those things later. Right now we'll study what is TCL and how this language works. Command language. Okay, can you please command language, some of the examples are copy command, or it might be date command and all. Let me show you something. Okay, this is a terminal. Okay, we'll call this as terminal. Okay, what is in case of command language? In case of command language, for example, I want to see the list of files. I'll give a command called ls. I'll have some files. Correct? No. So I want to give files like I want to give a list of files with proper option. I'll give space minus L. I'll give. Okay. What I'll get? I'll get the permission. I'll get write, read, all the details of it when it was created and all. Okay. Correct? No. So in this example, what we observed, ls is a command, space minus L is an option. Let me give in this way, ls without space minus L. Will I get the output? No, I won't get the output. What's the error we are getting? Command not found. Okay. Then what is very important in command language? The space plays a very, very important role. Correct? No? Space plays a very important role in case of command language. Okay. So that is very, very important thing you have to remember in case of this command language. Okay, and I'll call the ls as command, space, whatever the arguments you are going to give, options, arguments, both are one and the same. They are called as arguments, and each argument has to be spaced, should be spaced between them. Okay, if you have not given the space, it will be given error. That is called space, and space plays a very, very important role in command language. I'll give one more example. Okay, I'll give one more example. How in case of C language or C++ or any other language, what is the syntax of creating a variable? I have a value 5. I want to assign the value 5 to some variable. What is syntax? Int a is equal to 5. Correct? No, we used to do that. Int a is equal to 5. Okay. For example, we used to do that. What is that? We used to do like this, something like this. Correct? No, that is set. For example, in case of C or C++, int a is equal to 5 with operator called terminator. Okay, so this is called as initialization. I want to do this in case of command language. I want to do this operation with the help of command language. What is the command I have to use? There is one of the fantastic command, my dear friends. It's very, very important in case of NS2. The command is called as set command. Okay, very, very important command. I can call it as set command. Okay, how many arguments? As we all know the syntax of command language, command followed by space, followed by argument number 1, space, followed by argument number 2, space, followed by argument number, so on, whatever the number of arguments it consists of. Let me consider a set command. How many arguments required for set command? 2 arguments. Remember, okay, the first argument is called as a variable name, and the second argument is called as a value for that. Okay, whatever the value you want to assign to A, that will be this value, whatever the value you have. No, I want to assign this value to this variable. Okay, so you have to separate those 2 variables with the help of those 2 arguments with the help of spaces. Very, very important. Okay, so that is one more important thing. For this example, let me create 2 files. Okay, let me call one.txt an example. I'll write something, for example, hi. Okay, so I had created, I'll go back. Okay, I'll create the second text called as I think you all know, I forgot to say this. What is this VA? VA is an editor. Okay, we have many editors: VEditor, gedit, fooedit. Many editors are there. If you go for Python, also we have different editors. We have lot of editors. Whichever you are comfortable, you can use that editor. Okay, let me create the second file. And what is this txt? Txt is nothing but a text file. No, so I'm not happy with text file. I'll create something else. You create whatever you want. Okay, 2.txt. Let me give some data like how are you? An example, some data I'm writing. Okay, I'll go back this to this mode. Okay, so I want to copy the content of first file to second file. What is the command I have to use? Copy command is cp in case of Linux. Okay, cp space 1.txt followed by 2.txt. What is the importance here? I'm copying the content of second file to first file. I'm copying the content of second file to first file. We will get the error. Why we are getting the error? The reason is that I have to give the space. What is important here? Space is important. That is very, very out of this. What is CP? CP is a command. What is this 1.txt? Source. I mean destination. What is this 2.txt? Source. Whatever the contents here, that will be copied to 1.txt. Okay, so this is I don't want to make you to show the execution of copy command. My intention is I want to make you to learn in case of command language, space plays a very important role. Okay, so in the similarly, if I want to I had declared the value of a is equal to 5, that with the help of a command, fantastic command called a set command. How many arguments required for set command? 2 arguments. Which are those? Variable name, space, value. Okay, I want to use that a in case of your C++ or Java or Python or whatever. What or C? What will be the syntax commonly in case of C, C++, Java and all, or .NET? The common syntax is I'll use that a directly. Correct? No. For example, I want to add C is equal to a plus b. I want to add. What I'll use? I'll use that content directly. But in case of command language, if I want to use the content of any variable, please make a note of this, content of any variable, I have to use a very important operator called as dereferencing operator. Okay, which operator? Dereferencing operator, and that operator can be represented as $symbol. Okay, that operator can be represented as $symbol. Okay, what is the meaning of this then? Set b space $a. I'm assigning $a to b. No, I'm not assigning $a to b. I'm assigning the content of a. What's the content of a? 5. Understood? I'm assigning 5 to b. Okay, so what is the value of a now? 5. What is the value of b now? 5. Understood? This is the meaning of assigning the value, and this is the meaning of content of a variable. Content of a a variable. Okay, so these are very basics which are very much required when you keep on learning the things and all. These are very much required for you people. And next we'll go for this all about variables. Let me go with some procedure. Okay, procedure will call in Java, or in it might be in .NET and all. In case of here, C++ or C and all, we'll call it as function. Okay, procedure, function, method, all are one and the same. Okay, what is the meaning of procedure? Why we require procedure? To make the life simple, correct? No? Instead of having a very large program with a only main method or main function, okay, completely embedding everything in a single file, I want to divide the complete program into small fragments, and such fragments are called as procedure commonly, correct? No? So as I said, all this follows what? Command language. What is required? Space is required. So if I want to implement procedure in command language, what I require? Procedure command. What is the command for using the procedure? PROC. Understood? Okay, what is the command I have to use here? The command to execute the procedure is PROC. Space. What is the first argument I'm passing? The name of the procedure. What is the first argument? The name of the procedure. Space. Very importantly, space, open brace, and followed by close brace. What that consists of? Any arguments if you want to write. Any arguments if you want to write. Same thing as of here, object-oriented language. Like, for example, I want to write it as int, okay, main. For example, I want to pass two things, or else I want to go with not main, int add. I want to add two things. What I'll do? Int a, comma, int b, right? So this is syntax, right? And similarly, in case of your procedure, if you want to do with any procedure, I don't want to mention any kind of data type. By default, it will take integer. By default, whenever it requires, it will take fraction. I mean to say, decimal points and all, floating values and all. By default, it will take. Okay. So whenever I want to pass any arguments, I have to use the syntax. Okay. And if I want to begin the syntax in case of C or C++, what I'll do? I'll give the open brace. Correct? No? So if I want to close the method, what I'll do? I'll write some very important things and all. I want to close this. What I'll do? I'll close like this. Correct? No? Same thing. Okay. But in case of here, object-oriented languages, command language, we have to use a syntax of command language syntax. How to use a command language syntax? The command uses proc followed by the name of the procedure followed by open brace and close brace, which consists of the arguments followed by a space followed by open brace. That brace is the point where your procedure begins. Okay, that is a place where the procedure begins. Okay, if you feel like, let me write the procedure very neatly, shall I write this brace in the next line, open brace in the next line? No, immediately you'll get a syntax error. It's not about looking the beautification of the program and all. We are talking about the spaces, command language, correct? No? So how many arguments required for procedure? Name of the procedure followed by set of arguments followed by beginning of the procedure in the same line. You'll see all this beauty in your programs. When I go for the example, you can understand very clearly. Okay, so and you can close wherever you want, but begin should be in the same line. If you put the same brace in the next line, what the error will get? Argument missing. Correct? No, because procedure requires three arguments. Okay, procedure command requires three arguments, but you had embedded only two. Obviously, it will give the error. Okay, so indirectly, I'm using one more set of within that I had written set command. How many arguments required for set command? Two. Which are those? Variable, first one. Second one is value. Don't worry about it. Might be 10 lines of value. Don't get worry about the value size and all. Okay, the content of this, I want to put the content of this to this variable. That's all. This content, let me see later. I don't know what it is. Understood? Okay. So now let me analyze. Okay. Don't worry about this expr or the square root. Don't worry about all those things. Okay. So what I require, what I had mentioned, $A into $A plus $B into $B. We all know what is dollar. What is the dollar here? Dereferencing operator, or else content of A into content of A plus content of B into content of B. What's the content of A? 5. Wait, an example. In this case, we will take the example of 5 itself. Okay, 5 into 5 plus what is the content of B? 5. How we know? Because B also assigned with the help of the value A. correct? No, 5 into 5. So it will comes up with some value. Okay, that square root they are mentioning. Okay, that square root. If you want to use expression in Linux, we have to use a command called expr. Okay, if you want to use square root in Linux, we have to use sqrt. This is correct? No, this is a mathematical expression. So I'm using the command called expr. Okay, so square root sqrt. Okay, so don't worry about this large content. So this is the very last. No, don't worry about that. Whatever the things we have, that will be assigned to a variable name. That's all. I don't want to worry about what it consists of and all. Okay, so this value output we are returning here. Return. I don't want to return the alphabet C to the display screen. I want to return the content of C. I want to return what? The content of C. Hence, I'm embedding here $C. Clear? And puts same as of your printf statement, what you are used in your or system.out.println in Java, or cout in C++, kind of thing, or print in case of many languages, just print. So in here we have to use puts. Okay, whatever the double quotes are embedded, all the things will be displayed on the screen. Okay, if you would have used brackets, this is a function call. This is a function call. What is the name of the procedure? Diag. Correct? No? Diag. What is this 3 comma 4? 3 space 4. Sorry for that. Not comma space 3 comma space 4. These are the arguments. Okay. This 3 will be, this A holds a value 3 and this B will hold a value 4. Clear? Okay. Let me analyze. As A will hold a value 3, B will hold a value 4. What is 3 into 3? 9. Plus what is 4 into 4? 16. Correct? No? 16 plus 9, how much? 25. Correct? No? Square root of 25? 5. So what? Diagonal of 3 comma 4, whatever is that output we are displaying. I hope you got. So this is the method. I don't want to explain the content of the logic of the mathematics. Okay, I am very intended to get to know the people how exactly commands works, how exactly space works. Okay, this is the basics. Okay, similarly we have loops. Similarly we have other things. Okay, let me consider the first example as loops. Okay, a loop consists of, for example, a while loop. Okay, we all know that pre-condition loop, post-condition loop, iterative loops and all. While loop consists of how many arguments? 2 arguments. Which are those? Condition, all command language. It will work as of command language. Okay, while consists of 2 parameters or 2 arguments. First argument, second argument. Understood? For consists of how many arguments? 4 arguments. Initialization, condition, increment or decrement, beginning of the for loop in the same line. Okay, same line. If you have any doubts at any point of time, you can put up in your chat window. In the comment section, I can able to repeat, or I can able to help you people. Okay, so we have to go with the iterative loop as for loop or while loop with the help of command language only. Okay, if you have not given the space here, immediately it will show you error that the argument missing. Okay, this consists of a sample example. This consists of all the things. To say all all the iterative loops. Let me analyze. Okay, what is the procedure command requires? 3 arguments. Proc space. What is the first command? Test name of the procedure. Space. Or the second command? Set of arguments. Space. Or the third command? Beginning of the procedure in the same line. In the same line. Okay. So okay. And now we had used set command. How many arguments required for set command? 2 arguments. Variable name, value for that. Don't worry about all those things. What is that value and all? Let it be. Okay. Third command. Similarly, we have C and D with the same command called set. Okay. And for loop also requires how many commands? 4 commands. That is initialization, increment or decrement, condition, increment or decrement, beginning of the for loop in the same line. Okay, and if statement requires 2 commands, condition, beginning of the if statement in the same line. Okay, so this is the way how we can go with, and ultimately this will get a value once we call. Okay, so we are calling the command procedure here without any arguments, because I'm not passing any arguments here, right? I'm not passing any arguments here, so I can use as it is as test. Okay, so this is a simple example to explain you people how the command language works. So I'll make you to execute. I'll let me execute few examples before going for the next actual coding of your TCL scripts. Okay. So let me check out where it consists, where it is present. One second. Okay. Okay. Again, cd is also a command, correct? No. So it will make you to go. Change the directories and all. Cd. If I would have given space like this, it will not work. Why? Because cd consists of two. First argument, cd space dot dot. These are very important things you have to remember. Cd. Let me go within the desktop. Within that, I think my name, I guess. Okay. ls. cd d1. Let me go with some sample example. I'll tell you how to do that and all. Okay. Okay, we'll see one of the example which I can able to explain you people. I'll use gedit first dot. I don't know whether I had used tcl or okay. This not fine because I had not explained this. Okay. 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 Quickly, we'll go with the TCL also. Then we'll come back for the execution. Okay. Okay. This is what I had explained about the basics and how it works. And now we'll go within your actual working of your TCL scripts. Okay. These are the things. What the basics or what I thought. What I'm explaining right now is some of the basic steps which are required for TCL scripts. I mean to say network simulator scripts. Okay. The first step of your network simulator or NS2 script is we have to create an event scheduler. Okay, very, very important. You have to know it very particularly. Okay. One of the biggest class in case of Java, which is a main class, Java itself. By default, Java itself is a main class. Within that only we have container, panel, and other things. All those put together, we have Java. Okay. Hence, we are going to use Java as an interpreter. Okay. In the similar aspect, we have the main class, very, very main class of the complete network simulator itself. What is the class name? What is the important and very important class name? We have a class name called as simulator. This is a class name. Understood? The main class of your network NS2 is simulator itself. As I explained you people already that in the architecture I explained how what are required for me to get the output. One is animation file I require. One is trace file I require. Correct? No? Very two important things are. One is animation file. One is trace file. Correct? No? So let me go within the code now. Okay, how that works. Okay. So the first thing is I had created the event scheduler. Within that event, I mean to say, small open box will open. Small tab will open. Within that, I have to make some notes to create. I have to make some activity. Then only I can see the animation, right? So two important files I have to open. Which are the two important files I have to open? One is animation file. What type of animation we have in NS2? Network animation called as NAM. Okay. The second important file is called as trace file. Why we require the trace file? To analyze the output. At what time, how much amount of data transferred, how much amount of data received. All those things can be analyzed with the help of trace file. Okay. So I had created the event scheduler. The first step, please remember the steps which are very, very important. Okay. I had created the simulator step. First step called as simulator class or event scheduler I had created. This simulator class is also called as event scheduler. I had already explained. Okay. Within that, I am opening two important files. One is animation file and second one called as trace file. Clear? And to see the animation, to have a trace file, I want to make some nodes to create, or else it will be an empty site. It's same as an empty site, correct? No? So then if I have some buildings, first floor, second floor, I can able to see the animation. So what I have to do now, I have to create the nodes. I have created two nodes. For example, node is nothing but, you don't get confusion with the words. Interchangeably, we may use node, machine, system, sender, or receiver, or whatever. All are one and the same. Node is nothing but NODE. Node is nothing but an empty device. Okay. If you would have add up some routing mechanism, we'll call the same node as router. If you would have add up some switching operation, we'll call the node as switch. If you would have add up some memory and all, we'll call it as a machine. It might be laptop, desktop, or mobile device. Okay. Don't get confusion with that word. Node, technically speaking, don't have any meaning. Node is nothing but an end device. That's all. Okay. So I have two nodes. I have two mobile devices. Let me call the node one as first mobile device. Let me call the second node as second mobile device. What the next step I have to do? Simply keeping such node will make it work? No. We have to connect those nodes. Correct? No. If I connect those nodes only, we can able to. If I connect those nodes only, we can able to send the data. We can able to see the output. I have to create the connection. Once I created the connection, how to create the connection, I'll tell you all the details one by one. Okay. Once we create the nodes, once we set up the links, I have to how to set up the links. I mean to say that two nodes are created. Between two nodes, I set up the link. And what are the parameters of the link? How much? What's the bandwidth it utilized? Okay. What is the space it required? How much delay it's going to have? All the details will be done with the help of set up the links step. Okay. The next step is called as setting up the links. Okay. The next step, what we are called as configure the traffic type. I'll tell you very, very important thing. Okay. Even I think your teachers also said in their class, we are working on application layer. For example, I'm using Facebook, I'm using Instagram, or whatever. We are on application layer. If the application layer want to work finely, which is the fundamental layer which we require, transport layer. Correct? No? Without transport layer, any application will never work. Okay. If the application layer protocols to work finely, there will be a support of underlying layer called as transport layer. Which are the two protocols we can have in the transport layer? UDP and TCP. Correct? No? So what is the major thing we have to remember? We have to configure the traffic type in transport layer. Okay. If the transport layer protocol want to work once, we require application layer protocol. We can use application layer protocols also. Okay. So these are the 5 steps. I'll tell you the other next 3 to 4 steps in the next slide. Let me recall. The first step is we have to create the event scheduler, and we can call it as simulator big class, main class. Okay. And within that simulator class, I'm opening 2 important files. One is animation file, and second one called as trace file. Why we require the animation file? To see the output. Why we require the trace file? To analyze the output. Okay. And the third step is called as we have to create the nodes. Okay. Why to create the nodes? So what is the use of creating the nodes? To see the output. Something should be happen. No, to see. Correct? No. So there should be nodes. Simply creating the nodes will work? No. We have to set the links between the nodes. Correct? No. Once we set up the links, I have to configure the links. What is the bandwidth? What is the simulation delay? All the details has to be embedded for the links. Okay. Followed by the next step is called as I have to configure the traffic type. Okay. What is the meaning of traffic type? As I said, you people already that if any application has to work only when transport layer protocols will support. Correct? Only 2 protocols we have in the transport layer. Which are those? One is TCP and one is UDP. Okay. So the next step is called as we have to set the time of traffic generation. I mean to say, if I want to use a traffic generation, there will be a possibility of sending the data to the outside world. Outside world means nothing but internet. We all know it. Okay. Application layer is the topmost layer of your OSM model or TCP/IP model that will be in your machine. An example. Okay. If you want to connect to the outside world or somebody else, you have to go with traffic generation of the application layer. Which are the traffic generation protocols we can have? One is CBR and one is FTP. Okay, you may have a confusion. So we have only two protocols, but in our class they said many protocols. Yes, we have lot of protocols in application layer. Okay, some of the examples are HTTP, SMTP. Many protocols we have. Out of those, compatible protocols that are using in commonly in network simulators are CBR and FTP. Okay, what is CBR? Constant bit rate. Okay, or what is the meaning of constant bit rate? In the regular intervals of time, I have to send the same amount of data. For example, in the first iteration, if I'm sending 10 MB of data, in the second iteration, I have to send the same amount of data. In the third iteration, I have to send the same 10 MB of data. There will be opposite protocol. What will be the name of the protocol? Obviously, VBR, called as variable bit rate, where we can vary the size of the data. Okay. Along with that, we have one of the finest protocol of the transport layer called as FTP protocol. Okay, FTP protocol stands for file transfer protocol. Okay, why we require file transfer protocol? If we want to transfer a small size of file, we have to go with file transfer protocol. If the file size is very large, we cannot able to send the data with the help of file transfer protocol. We have to go with one more protocol called as TFTP. What is the meaning of TFTP? Trivial File Transfer Protocol. I hope you got the logic of this. There are two important which layers I'm speaking about? I'm talking about application layer. Okay. If this application layer want to work, which are the two supporting protocols we require? Transport layer. Which are those? One is TCP and one is UDP. Now I'll teach you one more thing, one important thing. Okay, there's a couple. I'll call it as couple, but it's not constrained that we have to use the same logic, but we can change the logic also. But commonly, with the majority of the researchers, they executed the programs with the help of this logic only. Clear? What is that is, if I'm using UDP in the transport layer, if I'm using UDP protocol, datagram protocol, I should use CBR in the application layer. It's like a tie-up they have to use. Okay, and so why we have to use the same thing? I'll tell you. If I'm using TCP in the transport layer, I have to use FTP in the application layer. So is it compulsory we have to use same protocols? No, but majority of the research they did a rigorous work on that, and they come to a conclusion that if I'm using UDP protocol, CBR protocol works fine in the application layer. If I am using TCP in the transport layer, I have to use FTP in the application layer. That's mapping. It's a kind of mapping. Okay. So once we set up the traffic, at a transport layer, once we set up the traffic in the application layer, at last I have to close the simulation. Correct? No, I had opened the create data simulation. That simulation has to be closed one day. I have to, once I find out the land after constructing the building, simply keep on constructing. No, I have to close it. I have to end the construction. I have to make the housewarming ceremony, and I want and they have to leave. Correct? In the same way, I have to close the simulation. How to close? With the help of termination. Okay, I'll tell you all the things. The last step of simulation is termination. I had opened the file here. Two important files called as NAM file and trace file. I have to close those files also. Okay, so let me go with the syntax now. Now the beauty of both command language and object-oriented language comes into picture. I'll tell you. What is the first step of simulator? As I said, in case of NS2, what is the first step? I have to create the event scheduler, or I have to main class called as simulator class. Correct now? So what is the command I have to use to create the object in case of, what is the command I have to use in case of object-oriented Java? New command. New is a command or an operator that will be used to create an instance of the class. Okay, many of the students have to understand very basic things. Why the object has to be created is that without the objects, can't we execute the class? 100% we can able to execute the class. Those objects are not at all compulsory to make the life simple. Okay, for example, class student. Okay, class student. Within the class, I have int marks, or for example, int average function. An example. Okay, I want to access that marks and average function. Is it compulsory to create the object for the class and to access the members? No, not at all. Okay, an example. I'll explain you people. I think you'll get to know the logic very clearly. Let me write the class as something like student. Okay, I'll create the class. Within this, I'll write it as int marks, an example, and int and a function called as average function. Average function. Okay, I'll close this. This is a class, basic simple class. I want to access the members of this class. Is that compulsory to create the object? No. With the help of class name only we can access. Similarly, of your regular classes, why we appoint the CRs of the class? For the easy operation of the class, correct? No, for the easy accessing of the class. Okay, if I send some message to CR, he will indirectly or she will indirectly turns to your class. So similarly, instead of using the class name, I think in a real-time application, the class names will be not so simple and sweet as student. Okay, in the real-time application or database application, it will be very large. Okay, student, for example, I want to mention a class name. What will mention? Students underscore fifth underscore CSE underscore B. That's a big class name. Can I use the same class name every time when I want to use the objects or when I want to fetch the data? No. We have to simplify the operation. How we can make the simplification, or how we can create the reference with the help of the object. Correct? Now, within this class, how to create the object? Student space, for example, space S is equal to new student of. What is the student of? It's a constructor. It's a constructor. Correct? No. So what is this new operator? Whenever I'll use new operator, it's same as of initialization declaration. I can do this also. Okay, I'll do this and then I can do this also. Correct? No. This is when a baby born. What will do? A baby has been born. That's all. That is what. It's male or female. I know. That's all. Correct? No. After some days, we will allocate some space for that baby. Some space, and we'll give some name for that baby and all. Correct? No. So that is what the memory allocation by default will be done with the help of new operator. Clear? Similarly, in case of command language, we have, if you want to create any object, we have to use new operator. Okay. For the contrast, I'll tell here itself. If you want to, can we leave the after I had created the object, I had used the object for all the operation. Can I leave the object as it is? No, we have to delete the object. Why we have to delete the objects? The reason is that we have to, the space can be reused by, or reutilization can be done by somebody else. This mechanism is called a space optimization. Optimization has to be done. Correct? No, I have many registers, 1, 2, 3. I have to add 2 numbers. If I use all the 3 registers, I can add. For example, add R comma register 1 comma R2 comma R3. The 2 registers will be added and it will store in first register. If I want to add one more number, is that compulsory to use one more register, new register? No, I can reuse the existing registers already, because R1 and R2 are already added. This operation is called as memory optimization. Correct? So how optimal you are, you'll be fine. Your programming will be really good. So once object has been created, after utilizing that object, I have to delete that object. In case of C++, we'll use an operator called as delete operator. In case of Java, what we'll do? We're not going to delete the object. By default, memory reallocation will be happen once the job has been done. Automatically, memory will be reallocated. Okay, no need to, you don't want to free up the object and all. By default, it will be reallocated in case of Java and other higher languages. No need to delete explicitly. Okay, so this is what the first step. Now, I'll tell you the syntax of command language. Okay, very, very important. Okay, one program, I'll teach you the very basics of everything. Later, you can easily understand the rest of the programs. Okay, what the command I have to use? Set command. How many arguments required for set command? 2 arguments. Which are the arguments? Variable name. Forget about the object in this simulator. Forget about all those things. I'm talking about set command, command language. What is a command? Set command. How many arguments are required? 2 arguments. Which are those? Variable name followed by value. I don't know what is this value. What is this bracket? What is this new? I don't want to know. Right now, I'm using command language. Command language consists of very simple thing is spaces separated by arguments. Correct? No? So what is a command? Set. How many arguments? Variable name, value. Done. My first language done. Indirectly second language. What is the second language I'm going to use here? Object-oriented language. Correct? No? So how the object-oriented language works? I have to create an object called NS. I have to create an object called NS. Within which class I'm creating? I'm creating this object within the simulator class. Understood? How I am creating? With the help of an operator called as new operator. With the help of new operator, I am creating the instance as NS instead of using simulator everywhere. If you want to fetch whatever the content within the simulator, I have to use simulator space that whatever you are fetching. Okay. Instead of using that or dollar simulator content of that, instead of using that, I can use very small object as NS. So is that NS compulsory? I am comfortable with NS called as network simulator. No, sir, I'm not comfortable. Just tell use yes, you can use it, no doubt. Okay. NS space new simulator. What is a simulator? It's a class name. Remember this. Don't never use this yes in lowercase. Why? Because these classes are not built by me. Okay, they're already built and the class name is in uppercase. Okay, you can check out any Java programs or any higher language programs. All the main class name will be in uppercase only. The starting letter of the main class name will be in uppercase only. Okay, so the object within the simulator class is created with the help of new operator. This is syntax. Okay, indirectly command language. How the command language works? So it is a command. First argument variable, second argument value. If this complete thing will hold by NS. That's all. This is the first thing. The second important. What is the second step I said? What is the second step I said? The second step is we have to create two files. Which are those? We have to open two files. Which are those? Animation file and trace file. How those files? If you want to open any file in case of C++, Java, whatever, how the files will be opened? fopen. If you remember the functions, we have functions called as fopen, fclose, and all. Correct? No. If you want to create, for example, let me explain this in a greater details. Okay. For example, I think you all know about file operation, fopen, okay, fclose. If you want, what are the first operation of the file? You can take the regular example. I'll take one file, normal file, book file. Okay. What is the first operation? You will go and buy the file. Correct? No, that's the first operation. Okay. That is, I can call it as creating the file. Okay. Not opening the file. Without the file, can you open the file? You have to bring the file from the shop. That is called as what? File creation. There should be a file to open. Okay. The second operation is file open. Okay, what will be the next operation? I can go with any operation. I can add, if some sheets can be added. I can remove some sheets from the file. Also, I can modify the sheets in the file. And that operation is called as file modification. What will be the last operation of the file? It's not close, to delete. Correct? No. Last but one operation will be file close. And at last, the last operation will be file delete. I don't want that file. I'll delete that file. How to delete that file? I'll remove that file or with the help of from the memory or whatever. Okay. So I hope you got the logic of this. If I want to, let me go with the syntax of that now. If I want to open any file, I have to use a command in case of command language called open command. Okay, forget about that. Let me go with the command language. What's the command I'm using? Set command. How many arguments are required for set command? Variable name, value. Forget about the value, what it consists of. Now, this is first language. What is the second language? Object-oriented language. Correct? No? How to create the object, how to open a file in case of object-oriented language with the help of open command. Understood? What is the command? If you want to open any file, open command. What is the first file I have to open? One is animation file and one is trace file. All the animation files will be having an extension of .nam. All the animation files will be having an extension of .nam. All the trace file will be having an extension of .tr. As we in case of Java, .java, right? In case of C, .c. Similarly, In case of, if you want to represent an animation file, I have to use .nam. If you want to represent the trace file, I have to use .tr. Okay, so and what is this out? Name of the file. You can give whatever the name you are happy, no problem with that also. Okay, out.tr, because it's an output file. Out.nam, it's an output file. Animation output. Why this NAM called as network animation? It's called as network animation. Okay. And after that, I had written a space. I had written one word, letter called as W. There are different types of modes in case of files. I think you might have been heard of in case of your lower languages like C++, Java and all. Like if you want to read a file, I have to use an operator called as R. If you want to write the file, I'm using a access modifier as W. If I'm appending some data or I'm modifying the data, I have to use a access specifier as A. Access specifier as A. And similarly, what I'm doing here, I'm opening those files, I'm writing the data to that files. Hence, we have to append a letter called as W here. I have to append the data called as, append the letter called as W. W stands for what? Writing the, I'm opening this file. I'm opening this file with the help of a command called as open. Within this file, whatever the data you're going to write, all the data will be there in a variable called as TF. That's all. The first language what talks about set command. Set consists of two variables, two arguments, variable name and value. Forget about that. Second language. What is that? Object-oriented language. If you want to create any object, I have to use an operator called as open. Okay. If you want to create a file, I have to use an operator called as open command. Followed by all the trace file will have an extension of .tr. All the animation file will have an extension of .nam. And these two files are opened with the help of a mode called as write mode. I am writing the data to these files. Clear? Okay. And ultimately these two files are present in which is the main class? Simulator class. Whatever you are going to create, whatever you have, all the data will be in the simulator class only. So I am pushing all the data created by trace file and animation file to simulator class. How I am doing that? Let me go with the next succeeding lines. Okay. $TF. What is the meaning of TF? The variable which we had created. Okay. Content of TF. What is the meaning of $TF? Content of TF. What TF holds? Out.tr. What NF holds? Out.nam. Correct? No? Content of NF. Content of TF. Okay. I am pushing all these data to NS file. What does NS consist of? Simulator class. What is $NS? Content of simulator. Understand? I am pushing all the data written within this trace file to simulator class. I am pushing all the animation data to simulator class. This is called as taking out all the data to the main class called as simulator class. Very, very important. Okay. For all the programs, it might be wired networks, wireless networks, semi-wireless networks, whatever the networks it might be, you have to use these three steps compulsorily for all the, irrespective of the programs, you have to use it. Okay. This simulator class creation, opening the trace file, closing the opening the animation file, pushing all the data to network simulator, simulator class, pushing all the animation file to simulator class. These lines are compulsory. It's same as of a header files or import statements in Java. Very, very compulsory. Okay. The next step, as I said, the next step is I had created all these things. I have to create the nodes. How to create the nodes? If you want to create any node in case of network simulator or simulator class, I have a subclass called as node subclass. This comes to the feature of inheritance. If you remember, if you want to access the features of the main class, what it'll do? It'll use a property of inheritance. Correct? No? And we can have, we'll call in many words. Parent class, child class, superclass, subclass, okay, base class, derived class. Correct? No? Many terminologies. Okay. So if as I said, node is a subclass of which class? For everything, simulator is the main boss. Correct? No? If you want to access the subclass of simulator class, I have to use the property of inheritance. Correct? No? And if I have two subclasses, student and the second subclass is, for example, section. Okay. If you want to use section, what I have to use? Student dot section. Correct? No? I have to use student dot section. you can inherit the properties with the help of dot operator. And similarly, if you want to inherit the features of your, if you want to use the features of simulator class like node and all, we have to use $ns. Okay, this is the beauty of your this is the beauty of your ns2. Okay, this bracket what we embedded, that talks about property of inheritance. What is the meaning of this? This node is a subclass of simulator class. How I know it's a subclass? Because I am using $ns. What is this $ns? ns is an object of simulator class. Instead of using simulator directly, I'm using $ns. What is the meaning of $ns? Content of ns. What the content of ns we have? Simulator. Hence, I'm using the subclass called node, which is present in your simulator class. And this is what about your object-oriented feature. Let me go back to one more language. What is that language? Command language. What is the command? Set command followed by node name. Give node name whatever you want. It might be set command consists of how many arguments? 2 arguments. Variable name, value. Variable name can be of anything. Give whatever the variable name you want. A, B, C. Usually in case of network simulator, the node name will be given as node 0, node 1, node 2 and all. So you can give those things space the value. Indirectly, object-oriented language, this follows the principle of inheritance. Okay, this node is a subclass of simulator. This $ns talks about it's an instance. So this talks about inheritance feature. Okay. Now I have created two important classes, nodes. I have created nodes, 2 nodes. Let me call the nodes as node number 1 and node number 0. Let me call. Okay. And I have to set up the links between those nodes, correct? No? I have created the nodes. For example, with the help of the syntax, let me take the example of this. Okay. With the help of the syntax, I have created 2 nodes. How to create the 2 nodes? Let me call the node name as node 1, node 2, node 1. And let me call the first node as an example, node 1. Created. Okay. In the sense that I have 2 nodes. For example, node 1 is here. And let me call node 2 is here. An example. Okay. If I create these 2 nodes, it's enough? No. I have to set up the links. Correct? No? How to set up the links? The link setup can be done with the help of, I have to set up the links like this. Okay. I can set up the links like this. How to set up the links? With the help of a step called as link setup. How many steps I require? How many parameters are 7 arguments? Okay. And all these operations, what we're doing, all these comes under which part? This all comes under simulator class, correct? No? Whatever the operation will do, all this comes under which class? Simulator class. So we are using the reference as $ns. Okay. This reference indicates we are doing the operation within the simulator class. How many arguments are required for setting the link? 7 arguments. What is the first argument I require? The type of link. Basically, there are 3 types of links, which are those simplex, half duplex, and full duplex, or sometimes it's also called as by default as duplex. Simplex is nothing but one-way communication. Either sender has to send the data or the receiver has to replay the data. What is half duplex? The sending and receiving can be done at different intervals of time. They can send the data, they can receive the data, but it should be done at different intervals of time. What is full duplex or duplex? Either say data sending and data receiving can be happen at the same time. It's called as full duplex. Okay. So the type of link, the next node, this link, what is this link? The type of link should be set up between which nodes? That should be set up between sender node N1 followed by destination node N2. How many arguments for this? Type of link, sender node, destination node, 3 arguments. What is the next argument? Data rate. What is the data rate between the link? What is data rate? First of all, the number of packets or number of bits sent per time. Okay, any type of data divided by time. An example is a bike caliber, right? Commonly we'll call 100 kilometers per hour and all. It's same as of your data rate or caliber. Okay, in the same way, data rate, what we have, number of data divided by time is called as data rate. Okay, followed by time. What is this time? How much time required to send the data? That's simulation time or delay required. And at last, I have to use one of the important part of this link setup is called as queue type. We all know that the nodes will maintain a queue, separate queues. Okay, such queues are called as input queue and output queue. Okay, one of the finest queue what we're using in case of network simulator to commonly called as drop tail queue. The queue called as what? Drop tail queue. What is the meaning of drop tail? Drop tail is nothing but a type of queue wherein which the data will be dropped always at the tail part of the queue. Okay, if the data bandwidth is somewhat not enough to carry the data between node 1 and node 2, in such situation the data, if it is going to drop, means that drop will, you can see, at the node 2 part, tail part of the queue. Okay, that is what exactly called as drop tail queue. Okay, so how many parameters required to set up the link? 7 parameters. The first is reference to simulator class. Second is type of link. 3 types of link: simplex, half duplex, and full duplex, followed by sender node, followed by destination node, followed by data rate, followed by simulation time, followed by the type of queue. Okay, we'll see the examples. I think you'll get to understand how they work. And what's the next step? As I said, you people, that after setting the links, I have to configure the traffic. Okay, I have to configure the traffic of the transport layer. I have to configure the traffic of the application layer. Okay, so the traffic layer, the transport layer traffic can be done with the help of this. This TCP is one of the protocol that present in a subclass. I think you have heard of the slashes and all. For example, if you want to check the directories, subdirectories and all, for example, movies, within that Kannada, within that, for example, certain movie and all, we have slash, correct? No? In the same way, this slash represents class and subclass. Okay, and this TCP is a class that present within the agent class. I'll tell you the beautiful aspect of this features here. What I'm doing, I'm creating an object. Whenever I see new operator, its job is to create the object or instance. Within which class? TCP class. What is the name of the object? TCP0. Object-oriented class, job done. What a command language? Set is a command. 2 arguments. First argument is variable name. Second argument is value for that. Okay. See, very, very important. I'm not, what I'm doing in the next step, I'm doing the reference to simulator class. I'm attaching this TCP protocol to the first object, first node. Let me call the node as node 1 or else node 0, whatever. I'm taking the content of TCP. Dollar indicates what? Content of TCP0. This TCP0 an instance of which class? TCP class. Obviously, whatever the instance it follows within the TCP, all the features will be there in this object. Okay, I am taking the features to node 0. Now node 0 becomes which protocol object? TCP object. Remember, again and again I'm telling, we are not labeling the node as TCP0. We are making the node to behave like TCP protocol. Have this in your mind. We are not making the node as TCP0. We are making the node to behave like TCP protocol. What are the features of TCP? It's a reliable protocol. If I send that data, we'll get an acknowledgement. All the features will be there in case of this class. Okay, it's not labeling the node. We are making the node to behave like TCP protocol. Remember this. Similarly, if to attach that node to the other node, we are going to use a command called attach agent command. Okay, I'm attaching this TCP0 object to an N0 object. Okay, and that N0 object is a class of which class? Node class. This TCP0 is an object of TCP class. I'm attaching this TCP0 to node 0. That's all. Okay, and similarly, we're doing for UDP protocol. And after that, I had not shown the traffic, application layer traffic. Same as of transport layer, we have to do it. Because as I use TCP, which protocol I have to use now of the application layer? FTP compulsorily. FTP compulsorily. If I would have used UDP in the transport layer, which protocol I have to use? CBR compulsorily. Understood? Okay. And at last, after doing all these things, what I have to do? I have to set the traffic size. I have to set the interval all between the nodes, and have to once we set up the traffic, I have to go for the last step of your simulation. What is that last step called as? Terminating the simulation. How to terminate the simulation? With the help of one of the finest class, what we are called as finish method or finish procedure. What the procedure consists? How many argument consists in case of procedure command? Proc command consists of 3 arguments. Which are those? Name of the procedure, parenthesis consists of parameterized one, followed by the beginning of the procedure in the same line. If it have written this, let me write very syntactically. I mean, let me write the program looks very nicely. If it have written this open brace in the next line, it will be ended with errors. Why? Because argument is missing. Correct? Okay. So what I'm doing within the procedure, I'm taking out all the objects created. Which are the objects created initially? One is NS object, one is TF object or TF file, and one is NF file. Okay. Animation file, trace file, and simulator object. All the variables are making it as global. Okay. And at last, what I'm doing, I'm flushing the data from the NS file. Okay, flush trace. I think if you would have used C++ or C F flush function, we have F flush function flush function. And similarly, we have flush trace operator or method that will flush out all the data of the NS object. What is this NS object? Which refers to which class? Simulator class. Whatever you have created, all the things will be deleted. And we have one more important thing is I had opened here, right? I had opened the file. And at last, what I have to do? I have to close those files. Close $NF, close $TF. Okay. And before doing all the, it's not top-down approach or bottom-up approach, my dear friends. I never said anything about that. If you want to write this finished procedure in the first line of your program, write it. No problem at all. If you want to write this NS simulator at the last, you can write it. It's not work as of your top-down approach, bottom-up approach. No. It will work with the help of command language. Wherever you write this, it will be created automatically first. This simulator class will be created automatically first. Okay. So at last, if you want to execute the file, what the command I have to use? exec space nam space. What is the meaning of nam? Network animator nam. What is the file name of nam? Out.nam. What is the meaning of ampersand? Address. Where this out.nam file has been created, that file should be executed. Then only all this will be does. You don't worry about that. Before executing, I'm closing, it will does. No, it's not like that. Once after executing this, then only it will do all this operation. Okay. So this is the way how we can terminate the file. Okay. I hope you got some logic on this. Now I'll go with one example. Okay. And I'll show you one or two execution. Thereafter, we'll have the theory part again. Okay. I think clear command we'll use commonly to flush out all the data. We all know it. Okay. So within this void, we have few programs. Let me go with the first file. Okay. Let me explain that first. What is that? First .tcl. I think we all know it. Okay. Before that, what is this NS2? I want to explain that first of all. Okay. This Linux, why I'm using Linux? Because NS2 is a software. Remember that. What is Linux? It's an operating system. Upon Linux operating system, I had installed Network Simulator 2 software. Understood? Upon Linux operating system, I had installed NS2 software. Okay. So I want to check. I had already installed on this machine. I want to check whether the machine is working or not with NS2. How to check that? By using a very important command called ns. Okay. I know that it will not work because always you have to go for root operating system. In your respective classes, your teachers will teach all these things. When you want to execute any program at any time, you have to go for root operator. I think in case of Windows, we have admin and others, right? In the same, similarly, in case of Linux, we have root and others. Okay. How to go for root? With the help of a command called sudo su. Okay. If I give the password, whatever I had given, it will go for okay. Okay. So now it has been, you can see the indication. I had explained this or not. This is a beauty of your, that's okay. I'll tell that later. Immediately when I go to root operating system, root user, immediately the tilde has been changed to hash. You can see this terminal initially. Let me open one more terminal. One more terminal. You can see here tilde here, right? Correct? Tilde and dollar. This indicates you are in some other user. Understood? When it comes to hash, it indicates you are in root. Okay. This is the beauty of Linux operating system. Okay, now let me go with the first program. Okay, so I want to check, for example, okay, I want to check whether ns2 is properly installed or not. Many of the people will do a mistake always like this. Okay, without having the installation, simply they'll execute, because ns2 will be not a constant software which will be always fine. It will break whenever we want, because installation of ns2 to a machine itself is a tedious job. Okay, installation of ns2 to a machine itself is a tedious job. We have a lot of commands to give. Okay, so let me check whether this machine is installed with ns2 software or not. Let me tell you the hierarchy of that. Okay, if I type ns and press enter, I'll get a symbol called percentage symbol. Okay, if I get the symbol as percentage symbol, that indicates your machine has been installed ns2 perfectly. Okay, clear? Okay, within that I want to check one of the important file, whether the animator is working fine or not. How to check that? Type NAM, sorry, press enter, you'll get a small window. This window is called as what? Animator window. This tells, okay, my system is installed with ns2. Within that, it's also installed with animator file also. Clear? Now, once it is installed perfectly, we came to know that it's installed perfectly. Let me go with the first execution. Okay, once it is fine, then only we have to go within that particular execution. Okay, let me go with gedit space first .tcl. All the files of your TCL scripts will be having an extension of what? .tcl. All the files will be having an extension of .tcl. Clear? Okay, so let me go within that file. Okay, this is what way we can have here all here the first program of your simulation tool called as first.tcl. What we have to see here, we have to see the first line as simulation step. What is this? We have created the simulator. Correct? No. After that, what I have to do? I have to open two important files. Which are those? One is animation file and one is trace file. Clear? Okay. What is the meaning of this? It follows command language, set space, enough space, some variable name, some value. Within that, I am opening a file called as first.nam. I am opening a file called as first.tr, and I am open with the help of write mode. Nam trace all for animation, trace all for trace file. I am pushing all the data to simulator class. Okay, you can check out here. I have written the procedure finish here only. It does not mean that once it opens, it will close. No, it's not like that. It will do all the operations, then only it will go for close. Okay, I have to create two files. The file names are two nodes. Which are the nodes? Node 0 and node 1. Within which class I'm creating? Within the node class, which is a subclass of simulator class. How we know that? This is a reference to your simulator class. I can label these nodes $n0 as yes, sender, $n1 as D. It's a label function. I can use label also. I can use color also. I can do all those modifications later. And I have to set up the link between these two nodes. How to set up the links? With the help of how many arguments? 7 arguments. Which is the first one? Reference to a simulator class. Type of link. Sender node, which is a sender node, $n0. Sender destination node, $n1. What is it? 10 MB. The bandwidth between the nodes or data rate between the nodes. How much data rate we have? 10 MB. Okay. Mega. What is it? B stand for? Not byte, bit. Why bit? Because lowercase b. If it is lowercase m, millibit. Okay, like kind of thing. Okay. What's the meaning of 2 ms? 2 milliseconds. Okay, the delay. And the last, type of queue. These are 7 important parameters to set up the link between this node 0 with node 1. Okay, I am using a protocol. I have to set up the traffic. Correct? No. What are the protocol? What are the protocol I'm using? UDP protocol. This UDP protocol is a class of which class? Subclass. Which main class? Agent main class. I'm creating an UDP instance and I'm attaching this UDP to node 0, first node. Okay, and I'm calling one more important thing I forgot to tell. If I'm using UDP protocol, the destination nodes are called as null. Okay, if I'm using TCP protocol, the destination nodes are called as sink. Remember, if I'm using UDP protocol, the destination nodes are called as null. If I'm using TCP protocol, the destination nodes are called as sink. Okay, so I'm making the node number 1 as null because I have created the null 0 and I'm attaching that null 0 to node 1. Okay, it's clear. Now we'll go with, after attaching the transport layer protocols, what I have to do? I have to attach application layer object. I'm creating the CPR. As I said, if I'm using UDP protocol, application layer protocol should be CPR. If I'm using TCP protocol, application layer protocols can be FTP. Clear? So CBR is present within a class called traffic, which is having a superclass called as application. Okay, within the application I have a subclass called as traffic. Within the traffic I have a subclass called as CBR. I'm creating the instance within the CBR class and I'm attaching that CBR to directly to UDP 0. Means for the first node. Initially the same UDP 0 called it as what? N0. Later they called it as UDP 0 and at last we can call it as CBR 0. Understood? I'm attaching it's not about attaching, does not mean that just labeling. We are incorporating or inculcating all the features of UDP and CBR to node 0. Okay. And at last, I'm connecting between UDP 0 to null 0. What is the meaning of UDP 0? N0. Correct? Huh? And what I'm connecting to other node? Null. What is the meaning of meaning of null 0? Node 1. I'm connecting node 0 to node 1. Okay, and I want to start the simulation. At what time I'm starting? If you have not given the start time also, by default it will start with a simulation of 0.0 second. Okay, and if by default whatever the finish time you had given, you have to give the time explicitly in the programs. Why? It is a event driven simulator. As it is a event driven simulator, we have to mention the time or closing time explicitly. At 2.5, this program or this method will call finish procedure. It will call. At what time it will call? 2.5 seconds. The complete program, I forgot to inform you people that the complete program will run with the help of one of the finest command called $ns run. What is the meaning of $ns? I am making the complete program to run with the help of run the simulator class. That's fine. The complete content of that will be executed. Okay. Let me execute this. How to execute any program in NS2? Okay. The command is ns space filename dot tcl. What is the file name? First dot tcl. The same file name what we had opened. Okay. Once we open this, I'll explain you people in a greater details. Please listen carefully. Okay, this window is called as default window of network simulator. Don't ever close this. Don't ever close this in a default window. If you close this, automatically this also will close. Okay, this will give the details of the version and other things in a greater details. Clear? And what about so you have to minimize this. And what about this part? This is the window that is open. First .nam. What the name we had given? First .nam. That is what your file. Okay. And I'll explain this is what about your animation window. Let me explain the meaning of this animation. What are the consists of? This is called as zoom in and zoom out. Okay. And this, if you want to edit anything, you can edit. Okay. If you want to separately zoom in the nodes, you can zoom in and zoom out the nodes. Okay. And we have this line is called as timeline. This line is called as what? timeline. Okay, and if you want to relay out, it's not looking nice. If you want to relay out, you can use the relay out or reset, whatever. Okay, so then this are this is the start of your simulation. This is the stop of your simulation. If you want to play backward, you can use this. And this is the speed mechanism. If you want to speed up the simulation or if you want to slow down the simulation, you can use this. Clear? Let me begin the process. What is this? Node 0. Yes. What is this? Node 1. T. Source and destination. I am running with the help of very minute seconds. So it's starting. Okay. So the time, if you have speed up this, it will also, this timeline also speed up. Okay, why it's not sending any data? Why it's not sending any data? Because in the program, 1 second. In the program, what we had mentioned. Okay, what we had mentioned here, we have to start the simulation. We have to start sending the data at 0.5 seconds, correct? Huh? So we have to finish by 2.5. So we can close this. We can see the window. Once this becomes 5, this becomes 5, it will start sending the data. I can check out here. Once it becomes 5, it will start sending the data. It's clear? It is sending the data from sender to destination. Okay. Once this becomes 2.5, this will close the simulation. I hope you got the logic of this. Okay, I hope you got the logic of the first program called how the basic nodes can be created and how we can do this. Exactly when it becomes 2.5, it will finish the simulation. Okay, so this is called as animation window. Once we executed the animation window, automatically the trace file will be created. Automatically the trace file will be created. You can check out first.tr. Okay. First.tr will be, sorry, not this one. Here we have. First.tr will be automatically created. Automatically it will create. Okay. Okay. So this is how the animation window works in case of Network Simulator 2. Okay. And as I said, one file called as trace file will create. No, automatically it will create. By default, it will create. Okay. So the trace file majorly consists of what is this trace file? Why we require trace file? Trace file is to analyze the output. The data has been moved at what time, how much data, from where to where. As it is a simple node, we can tell we have only 2 nodes. Some data has been moved from this node to that node. But when we go for the detailed analysis, the node movement is very, very important. Okay, so at that situation, we require the trace file. Okay, so how the trace file will be done? The trace file operation consists of mainly 12 fields. How many fields it consists of? 12 fields. What the first field? Event type. You can check out here the type of event. Okay, the second field is time. The next field is from node. Okay, I'll tell you the greater details of it. What is the meaning of event? What type of event? We have various versions, various types of events we have. If the field is R, we can call it as a receive. If the field is plus, we can call it as enqueue. In queues, we have different operations like enqueuing, dequeuing, and all. What is the meaning of enqueuing? Inserting the data to the queue. What is the meaning of dequeuing? Deleting the data from the queue. Correct? No. What is the meaning of draw? What is the meaning of D? D stands for drop. Understood? So this kind of operation can be have in case of event, and sometimes some packet has been dropped. We can indicate it, that will be indicated by D. Okay. So the next field indicates time. Okay, my dear friends, it's not so simple to analyze the trace file. The trace file is very large. How much time we had taken for the first program? 0.5 to 2.5. Okay, it will generate the granular level of trace files. That is 0.00001, 0.502, 0.503. That level of granularity we can able to analyze. Okay, so the second column indicates time. You can check out here 1.356. Okay, what actually it does 1.3, 1.4. No, it's not like that. Each and every minute time it will consider how much amount of data will be transmitted from this node to that node or that node to this node. Okay, the next column indicates from node, next column, fourth column indicates two nodes, from which node to which node. Okay, and for example, I have three nodes: node 0, node 1, and node 2. In that situation, if node 0 want to send the data to node 2 directly, it has to send the data via node 1. For example, initially it will send the data from node 0 to node 1. In such situation, it will be 0 to 1, and after some time it will be 2 to 1 to 2. Okay, I will see all those things later. Okay, packet type, what type of packet, whether it's acknowledgement or TCP, CBR, what type of packet. Packet size of the packet, how much packet you are sending. Flags, no need to worry about this flags. If why usually the flags will be there in networks, especially if any researcher or any budding students or anybody, if they want to build up something in this things and all, they can use this flag fields. Okay, FID stands for flow ID. Why? As this is only one flow, we have only one path between the sender and destination, we can easily analyze. If we have 50 nodes, 100 nodes, and 100 flows we have, in such situation, we cannot able to analyze. In such situation, we require flow IDs, which is the flow number 1, flow number 2, and all. Okay. Sender address, destination address. We are not going to use the actual IP address. Okay, we are going to use the address in this fashion. If the node is 3, the sender IP address will be 3.0. If the node is 2, it will yes, you can see here the destination node is 0.0. The actual destination is 0.0, but the immediate I'm sending the data to this 2, and then this 2 will send the data to 0. The final destination address is 0.0. And what is this 15? Sequence number. Why we use sequence number in networks basically to avoid duplicacy, to avoid redundancy. Okay. Hence, we are going to use this 15 here. Okay, sequence number here. Okay, and the last field what we have called as packet ID. What is the meaning of packet ID? The individual ID will be given for each and every packet also. That's called as packet ID. Okay, so these are the various fields. How many fields we can have in trace file? Totally 12 fields. Which are those? Event type, the type of event like receive, enqueuing, dequeuing, drop, time, the simulation time, at which time, at what time the data has been sent, from which node to which node, from node to sender node, and packet type, the type of packet, the size of the packet, the flags, default flags, followed by the flow ID, followed by the sender address, destination address, sequence number, and packet ID for avoiding the duplication of packets. Okay, so let me see the file. What are the trace file we have? gedit. It's automatically created. I have not typed and all. Okay, first dot. Okay, first dot tr. Let me check out. See the output. Okay, see, if you want to have a transition from 0.5 to 0.6, you think about a granular level of research or granular level of outputs what it's got. Okay, 0.5, 0.50, 0.51. To change from 0.50 to 51, it's having almost 10 iteration. Okay, so this is what, to change to 0.6, see, it took this much amount of iteration. Okay, so each and every minute things, at what time, what flow, how much data, how much flow, everything can be analyzed with the help of this trace file. How many fields it consists of? 12 fields. Which are those? First field, event type, simulation time, sender node, destination node, the type of packet, the size of the packet, flags, the sender address, destination address, or the flow ID, sender address, destination address, sequence number, and packet ID. Clear? This is what, and this is what the flags. No need to worry about this flags. Okay. See about the file is not so simple. I'll ask you to. I'm in the exam. I'll ask you to compute number of packet sent. How to compute? Plus indicates what? Enqueuing. Minus indicates what? Dequeuing. I want to have a count of number of packets received successfully. Can you count R here? How many R's you can check it out? Okay. 1 R, 2 R, 3, 4. Can you count like this? It's not so simple. It's not so simple. Correct? No? So how we can do that? This can be done with the help of post-processing operation. I'll tell you that in a greater details. Okay. I'll tell you that in greater details. Okay. Now, let me go. Let me close that file first. Let me close that file first. Okay. Now let me analyze this. Okay. I'll take 5 minutes break. Okay, my dear friends, we'll take 5 minutes break. Exactly, the time is 3:45 in my watch. Exactly at 3:40, I'll come back and I'll start your session. Okay, thank you. Guys, welcome back. I'm going to deal with different aspects now. So far, I think I had explained about trace file and animation file of wide networks. Let me go with different examples now. After that, I'll go with the second category of wide networks. I mean, networks called as wireless networks. Okay. Let me go to the second example, how that works. The second example within the wide networks is, let me go with gedit second.tcl small changes. The first example was with respect to UDP protocol. This example was with respect to TCP protocol. And in the first example, I think the same thing, no changes, everything is same. Only we are using TCP and we are using FTP protocol. Okay. So let me execute this also and I'll show you. Before that, you please carefully see this, particularly NS for execution we require NS, right? First dot TCL. Please carefully see this. Okay. Please carefully see this. We have flow of data, completely flow of data, correct? No. Now you do one more thing. We'll go with the execution of the second one. Okay, we'll go with the execution of the second program of TCP. The first one was UDP. Okay, you same thing, only changes. The first one is UDP, the second one is TCP. Let me show you the output of the second one. Okay, we got two lines here. Have you observed that? We got two lines. One is packet is sending from sender to destination, and other one is we have the packets which sends from acknowledgement from destination to sender. Okay, that is the major difference between TCP protocol and UDP protocol. In case of UDP, we have only the data sent. In case of TCP, we have the data also sent, and we also get the acknowledgement, by which for this packet, this acknowledgement, for this packet, this acknowledgement. Yes, the data is reached successfully. Okay, that is a major difference between TCP protocol and UDP protocol. Okay, let me go with the next example. Okay. Okay, a small example. Let me see this. In case of this example, I had taken 4 notes, which is the first program of your syllabus, actually. So I am not going to point with the help of the syllabus. I'm not going to explain. Generally, let me explain. As usual, we have network simulator, class, animation file, trace file. Finish whenever it call, it will be when this will be called. At this point of time, it will be called. 2.5 will call that function until that it will execute. How many nodes I'm creating here? I'm creating 4 nodes: node 0, node 1, node 2, node 3. I'll call first node as sender, and node 1 as intermediate node, node 2 as destination 1, node 3 as destination 2. Okay, you can imagine the topology of this. Understood? Okay, so what I want to tell you is this protocol is a combination. This program is a combination of both TCP and also UDP. This is not in your syllabus. I'll tell you. Okay, both combination. First program with respect to UDP protocol, second program with respect to TCP protocol, and this is corresponding to a combination of both TCP and UDP protocol. Okay, so that is a major difference you have to remember in case of TCP and also in case of UDP protocol. Okay, and here we can check out here the connection between node 0 to node 1. The link has been set up between node 0 to node 1. Okay, connection between node 1 to node 2 has been set up, this 2 nodes, and ultimately connection between node 1 to node 3. Okay, you can imagine how the protocol, how the topology looks like. Okay, and I'm setting TCP 0 to node 0. Obviously, the first node will behave like a TCP node. If I'm using TCP protocol, I have to attach FTP protocol of application layer, as I said already, and this TCP will be attached. Obviously, the FTP also will be attached to the same protocol or same node, and the first node will behave like a TCP. Now, for the same node 0, I am also attaching. We are also attaching UDP 0. Okay, and for same node, we are attaching UDP CBR 0. Clear? TCP of the transport layer, FTP of the application layer, UDP of the transport layer, CBR of the application layer. Okay, all these things we are attaching to the first node. Okay, and we are calling the sync node as node 2. Node 2 is the sync node, first destination. Node 0 is the TCP sender, node 2 is the TCP destination. And I'm calling node 3 as CBR destination. Okay, node 0 as which sender, UDP sender, node 3 as UDP destination. What about node 1? It will behave like an intermediate node, middle node. Okay, so this is just a program what we're taken. Let me explain, with the help of animation, how it looks like. Okay, somewhere I think I had changed the things. Let me check out. Let me save this and give the clear command. Okay, let me execute this. We are getting an error in the first line. Okay, we'll check out. While explaining, I had inserted some character somewhere. It's not so easy to eradicate small, things. As it is a command language, if we would have embedded a small dot also here and there, it will give an error. Okay, I hope so. You got the logic. Instead of wasting the time, I can explain the next logic. I guess let me check out that later. Okay, what the extra thing I had added. Okay, no problem. Okay. Now let me go with the next program, that is ns4.tcl. Okay, this with the help of graph. Let me explain the logic of that. Okay, to check the graph in ns2, how many axes are required for plotting any graph? How many axes I require to plot any graph? We require x-axis and we require y-axis. Correct? We require 2 axes to plot the graph. Okay, so let me create a dummy file. Let me create a dummy file. Vi space something called 3.txt, a dummy file. Okay, I'll add up some values here. Okay, let me take the values as 2. I'll press I. Okay, I'll press I, and I'll take the values like 2. Okay, well, I think I'll go with JDit only, no problem. Okay, gedit 3.txt, an editor. Okay, so I'll add up 1 space 2, 2 space 3, space 3, and 4 space 5, and all. Okay, the how many axes we require to plot any graph? A simple graph, we require 2 axes. The first column always represent the first axis, and the second column always represent the y-axis. Okay, so let me plot the graph. Let me plot the graph. How to plot the graph? I'll save this file. I'll save this file, and I'll close this. I'll plot the graph. How to plot the graph? Let me explain you people. Okay. If you want to check the dimensionality of the graph, or what are the attributes we can include for the graph, we can use a command called xgraph and press enter. Okay, immediately it will display. It will display the graph. It will work. Okay, so no problem. I will go with the example only. So we have a graph. So I'll give the input as for graph. It requires an input file. Let me call the input file as 3.txt, and let me press enter. This is a graph. Okay, and the first column what we embedded, it's x-axis, and the second column what we embedded is the y-axis. Okay, let me give you some modification for the graph, because directly if I would have went for any like kind of network examples of the graph, it will be not so good. So what I'll do is I want to name the graph as I want to give a title for the graph. Let me call the title as title option as minus. I'll give it as minus t for title of the graph. I'll call this as throughput, throug throughput graph. Throughput, and x-axis name as something like a random example, some time. Okay, and y-axis minus y, an option, and I'll call it as let me call the y-axis as packets. Okay, and then space the input file name. Let me take the like this. Okay, what the name of the file we had given? What the throughput file? What the file name for the graph we had given? Throughput. What is the x-axis name we had given? Time. What is the y-axis name we had given? Packets. Understood? Okay, so this is the one we are required. Okay, so similarly you can do the modification for the graph whatever you want. Okay, so usually we wish to plot the graph using the trace file. Commonly we use the trace file to plot the graph. Usually we'll use the trace file to plot the graph. Okay, so now what I'll do is I'll go with how to plot the graph using a trace file. It's not so easy to analyze the trace file. So there is a post-processing operation. I'll explain this here with the help of this PPT. Okay, so called as post-processing can be done with the help of one of the finest tool what we are called as AWK. Okay, one of the finest tool what we are called as AWK tool, and it is most powerful tool and mainly designed for text processing. Okay, and as I said you people that in the trace file is very huge. Okay, I ask you to calculate the number of packets dropped. You have to check what the first column, all D you have to count. It's not so easy. It's a huge line. So there is a method how I can apply this awk script to that file. Which file? Trace file, to extract the data whichever I require. Hence, this awk is also called as data extraction tool. What type of tool it is? Data extraction tool. This awk consists of three important block, followed by rules block, followed by end block. Begin block always consists of begin keyword, followed by open brace, and whatever the initialization and all we can do in the begin block. And the rules block will write the actual work, actual data extraction we are writing in this block, followed by end block. End block consists of closing the things, like number of data, whatever the closing we can do in the end block. Okay, let me go with one example. I want to calculate the number of packets dropped. Okay, so let me begin a variable called as drop is equal to 0. No need to mention the data type. By default it will take as int. And what I'll do, $1, if $1 indicates, what the meaning of $1? First column, the content of first column is equal to D, drop. Okay, we all know it. The first column of the trace file indicates the type of events. What are the type of events I can have in the trace file first column? Send, receive, packet drop, and packet receive. Correct? No? R, S, D, plus and minus. Plus stand for encrypting the data, packet sending sending the packets in the data. Minus indicates packet dropping, deleting the data from the queue. Okay. So if it is D, I can indicate that it's a dropped packet. So I have to count all the packets. If $1 is equal to D, I have to take out these two columns. It's not like that. Whatever the columns you want, you can take out. Okay. So this is the important condition. And end is nothing but just a closing statement. Okay. If you want to execute the awk, I have to use a command called awk minus f. Minus f is an option. You are extracting the fields. Which fields? Applying this awk on which file? This trace file. Okay. Let me explain with an example. We'll get more knowledge on that. Okay. We have many awk scripts here. Let me apply awk script on second file. What, first file or second file? Okay. Let me show you the first awk script first. Okay. Let me take the awk script of which I'll take. I'll take the awk script of throughput.awk. Okay. Let me show you the awk file, and all the awk file will have an extension of .awk files. Okay. gedit. Why we require the awk script? To check out, to extract the data from the trace file. Why we have to extract? Because the trace file is very huge. We cannot able to count, or we cannot able to do it manually. So we are going with the awk script. Okay. How many parts we can have in the awk script? 3 parts. Which are those? Begin part, rules part, end part. Okay. Begin part, what we're doing, we're taking the packet is equal to 2 variables declaration, time is equal to 0. This is what about the rules part. Okay. This is all. This completely what about your rule section. What in the rule section I'm doing? $1. What do I mean of $1? The first column of the trace file is equal to R, and what is the logical end indicates? All conditions node. What is the meaning of $3? Sender node. What is the meaning of $4? Destination node. If $3 is equal to 0 and $4 is equal to 1, I have to do this operation. What I have to do? Packet is equal to packet plus $6. What is the meaning of $6 in the trace file? You can remember. I hope so. That is trace file. $1 indicates type, $6, 1, 2, 3, 4, 5, 6 indicates packet size. Correct? No? What is the meaning of throughput? First of all, number of packets sent divided by time. For example, I have 5000 MB of data. I will send 5000 MB of data at, for example, 2 hours, 1 hour. That is called as throughput. So I want the complete size divided by how much time. So what calculating the complete packet size. Initially, the packet is 0 plus what size of packet? If we encounter the first data, I'll add up to this. For example, 50 MB. In the next iteration, again, if I encounter R and sender is 0 and receiver is 1, I'll add up to that. Ultimately, we'll receive the final value of packet. Correct? No? Similarly, time also will receive. Okay. So percentage F is float because time will be in the float fashion, and percentage D because the packet will be not in the fraction part. So it will be in this fashion. Okay. And ultimately, I'm displaying the output, throughput of percentage of Mbps. Why? Because packet. What is the meaning of packet? The total packet size divided by time. That's called as throughput. Number of size of the packet divided by respective time. Why we're taking into 8 divided by 1000 MB, 1024? Because I am mentioning this with the help of Mbps, megabits per second. What is the meaning of mega? Mega is nothing but 10 power 6. Correct? No? So what I'm doing, bits per second. What is the meaning of bits per second? Bits, 1 byte is equal to 8 bits. Correct? No? Mega, why I taken? Because I'm converting that to 1024. So we are taking megabits per second, BPS. So if you close this, and how to execute any awk scripts? AWK space minus F space, what is the awk script file name? Throughput.awk space. I'm applying on which trace file? Let me apply on second trace file. Second.tr. Correct? No? I'm applying on this file, okay, to extract the data of this. So what the files I'm extracting? I'm extracting the data of the time, simulation time, the respective simulation time, and packet size. Correct? No. So once after doing all this operation, I'm receiving a throughput of 7769.82 something Mbps. Okay. Is this clear? This is the reason how we can able to extract the data from the which file? Trace file. Let me see the trace file of second. You can wonder how big it is. Okay, let me show you that. Okay, see this. This is the big size. We have to count the R. Correct? No, R. It's very huge. It's very huge. Okay, it's not so simple to count. It's still here. So think about the trace file. It's very huge. Okay. Can you able to count all these things? It's not so simple. So we are checking if the first column is R, take out $2 time, and it has to take out dollar, I think 12 packet ID. Okay. Packet ID. Packet ID. Okay. So this is the way how we can apply any trace file using any aux script using trace file. Okay, that is what exactly will do the post processing operation. Okay, and if you learn these basics corresponding to wide networks, you are done. You are totally done. Okay, so the next important thing is, as I said, xgraph utility, and we have manual for that xgraph also. I'll share you that also later. And this xgraph, as I said, xgraph is a command followed by the value of x parameter, the value of the y parameter, and the title of the graph. At last, the file name. Okay, at last the file name. Okay, let me explain you with the help of the same example. Okay, I had displayed, I want to plot this graph. I have x-axis values as time and y-axis values as the packet ID. How to draw? It is displayed on the terminal itself. Correct? No? How to draw that? I'll explain you people. Please give your attention. Okay. Once I executed this, I got the output like this. Correct? No? Instead of displaying on the terminal, what I'll do is I'll redirect. For redirection, we have to use a symbol called as greater than symbol. Redirect it to some plot dot something, lt dot whatever dot or something, txt, any input. Okay, I am redirecting whatever the output it was displaying in the terminal right here itself. I am redirecting that to one more file. Why I am redirecting? Because if you want to plot any graph, that the input should be given with the help of some text file. Okay, all the data which are displaying here, I am redirecting that to this file. Understood? Okay, so now let me see that file. What is that file name? gedit.lt.txt. Okay, what is this? We have the output which was displayed on the desktop. I am making it to display here. Okay, so what I'll do is using that file, using that lt.txt, let me plot the graph. Okay, what is the command for the graph? Xgraph. Correct? No, I had already plotted. I'll use the same commands. Okay, xgraph space. I wanted to plot throughput only with respect to the first column is time, second column is packets ID. Okay, and what is the file name I have to give? lt.txt. Correct? No, that's the file name. But I'm getting the error at which line? 292, the last line probably. Why? I'll tell you. This is very, very important. The xgraph can be plotted only for the inputs data that should be number or fraction part. If it is of something else, it will not plot. Okay. If you go for the last line of your code, there is words as throughput 77 something. Can you plot the graph for characters? No, we cannot able to plot. So remove this line. Understood? Remove this line. Now save the program. Now save the file. Okay, and now try to plot the graph. Okay, give the command called clear and now plot the graph. Okay, you'll get the output. Okay, so what the file name? What the file name we had given here? Throughput. What is the x-axis name we had given? Time. What is the y-axis name we had given? Packets. Okay, so this is what exactly what we have with the help of xgraph tool. Okay, this is what we can have in case of you know uh, using the this kind of experiments. Okay, so this all we are going to do in your lab exercise part. As a part of that, we are going to use all these things in your laboratory sessions. We are going to execute all these things in your laboratory part. And one more thing is, very important thing is, we have to know about wireless networks. Okay, wireless networks also does the same, the simulation part, everything is same as of here the wired networks. The only thing is we have to change the inputs. Okay, so let me go with one simple explanation and I'll stop. Okay, and will stop. Okay, so if you would have see this wireless networks, why we require all these parameters? Because wireless networks consist of various properties, various different properties, and except this, the execution, the simulation, the trace file, everything is same. Okay, I hope so you got some knowledge on network simulator, basics of networks, network simulator basics, and how the plot can be graph can be plotted, and all those things I had explained in this session. If you have any doubts at any point of time, you can put up your question. If no doubts, if anything to ask, you can put a message to my mail ID. I'll surely help you people. And if nothing is there, I'll wind up the session. The wireless networking part, the wireless part, and other rest of the parts, I think your teachers will deal in a class. And if time permits, I'll take up the session again in future. Okay, this is the end of first day workshop on network simulators. Thank you so much, guys, for listening. Thank you so much.